Hello everyone. My name is Suiffi Hassan. I am a civil engineer and a PhD student on the National School of Electrical and Mechanical in Morocco. In this presentation, I will talk about an important subject that is the study of the durability of concrete composites mixed with polypropylene fiber, programmed in this international conference on fracture and structural integrity. The plan of this presentation is focused on the following points. First, an introduction. Next, I will take the problem of using propylene fiber, especially on concrete cracking problem. Then I will talk about the role of fiber and explaining the experimental program of durability indicators. Then I will take about laboratory tests. After, I will analyze the results and comment on them, and finally, I will present the conclusions. Nowadays, the technique of adding fiber to a cement matrix constitutes an area to be explored in the field of materials reinforced with polymers in the field of construction and civil engineering. These composites are distinguished from other composite materials intended for industry and transport by the variety of type of materials and fibers, as well as the various types of additions, making possible a large variety of combination of or of mixture there. With the diversity of composites building products, it's become increasingly difficult to compare their property and performance of the construction needs or rehabilitation, which must meet several criteria and requirements: structural, thermal, economic, and environmental. Generally, the use of fibers, therefore, has a cracking or trading effect to alone shaded intervention. Depending on the shape, the nature, and of the fibers used and their implementation in the matrix in which they are incorporated, the role of the fibers results is generally in improvements in the cohesion of French concrete, to deformability before rupture, 3 the flexile intensive string, 4 in the durability and post-cracking string, 5 the shock resistance, and fatigue resistance and the fire resistance. In our case, we will focus on the durability of composites with the polypropylene fibers. In this slide, I am going to talk about the materials and methods in order to study the effect of polypropylene fibers on the durability of cement-used composites. Several experiments tests were carried out in the laboratory. The composite was tested with different volume fractions of polypropylene fiber as 0.05%, 0.10%, 0.30%, and 0.50%. The composite of the matrix is the sand, the normal sand. It comes from the carrier of the city of Kenitra in Morocco. Secondly, the cement Portland, it's composite of class CPG 35 as defined by the standard. The composition of the concretes used is a cement matrix made up of gravel 1 and 2 from the Kenitra cartridge. In this experimental, we use the fiber chosen by several types. In this study, we used the Cherkaoui fibers and is selected from among the most widely used in the building and civil engineering market. In this slide, we show the experimental program. The experiments were carried out at the level of the public testing and the laboratory. The standard specimen of 150 millimeters per 300 millimeter dimension were obtained by mixing gravel, cement, and fiber in accordance with the standard. First, raw concrete mix was prepared to be considered as the reference, as shown as in the figure. The same composition was obtained for the concrete matrix in all mixture with polypropylene fiber. For the test protocol, the porosity test consists in measuring the open porosity, which characterizes the ratio of the total volume of the open pores of the sample to its apparent volume. The specimen showed in the figure are obtained by mechanical coring on the cylindrical specimens. The procedure adopted is that recommended by the standard, and the test consists of weighting the samples in air and then in a liquid of known density. The gas permeability test is carried out with the constant load permeameter recommended by Cambiro. Its purpose is to measure the oxygen permeability of hardened concrete test bodies. This is a laboratory method applied to model and core test specimens of structure within the limits of the dimensional tolerance imposed by the measuring cells of the device. The test consists in subjecting a cylinder specimen to constant pressure gradient. The apparent permeability is measured according to the standard. For the diffusivity, the objective is to determine the diffusion coefficient of the chloride ions following tests in saturated conditions of migration under a nuclear field in non-stationary mode according to the French standard. At the end of the test device, the sample is cut parallel to its axis. The section is covered with the isolation of silver nitrates in order to determine the depth of penetration of chloride ions. In this part of results and discussion, I am going to talk about the effect of increasing percentage of fiber in the concrete of the durability and the indicators. In the reference states at 105 degrees Celsius, the porosity of the various non-fibrous and fibrous matrix is equivalent of the order of 13.2%. With the increase in the dosage of polypropylene fiber, the porosity increased by 4.55% on average compared to non-fibrous concrete. As you can see in the figure, it is certain that the presence of polypropylene fiber in cementitious composites results in the connectivity of the pores of the composite with concrete and consequently an increase in the pore volume, but this porosity remained low compared to the other matrices with the other synthetic fiber. This is consistent with research on the porosity of cementitious composites. In these pictures, we show that the polypropylene fiber dispersed in concrete. So The accessible porosity of polypropylene fiber concrete increases with the percentage of fiber width is explained by the fact that the adhesion between the polypropylene fiber and the aggregates forms cavities connecting to each other. The gas permeability of the various non-fibrous and fibrous matrix is equivalent of the order of 97.3 with the dosage of polypropylene fiber of 0.10%, the gas permeability increased by 1.34% on average compared to the concrete without fibers. As you can see in the figure. All the concrete compositions have relativity allow intrinsic permeability of the order 19.8. It can be seen that concretes without fiber generally have permeability close to those containing polypropylene fibers. According to figure, we notice a small increase in permeability as the volume fraction of polypropylene fiber are increased. For the effect of polypropylene fibers on the diffusivity, the chloride ions penetration tests in the sample of the different polypropylene fiber matrix show that there is a little difference compared to the control concrete without fiber. As with the permeability, there is a slight increase in diffusivity with the dosage of 0.10% polypropylene fibers, approaching 7.25% on average compared to non-fibrous concretes. For the effect of PP fibers on the fire resistance, the objective is to study the strength of polypropylene fiber on fire resistance in concrete. The concrete mixes are prepared using volume fractions 0.10%, 0.30%, and 0.15% polypropylene fibers in order to take into account the accuracy of the test results. 3 tests were prepared from each group of concrete mixes. All were maintained in standard cure for 28 days. After the curing period samples, each group was exposed to 300 to 600 degrees Celsius. For temperatures, for different temperatures, the composite with 0.15% fibers exhibits the last loss in compressive strength. This loss is increased at 6 hours of exposure for the two temperature ranges. In the case of concrete with polypropylene fibers, the fiber melts at 160 degrees Celsius, creating voids in the concrete. Vapors pressures is released in the newly formed voids, and explosive spilling is greatly reduced. Here we show the fiber-reinforced concrete specimens before and after being exposed to 600 degrees Celsius. For the range 0.15% fibers in the concrete. The maximum composite strength at 23 degrees Celsius was determined for the 0.15% polypropylene fiber composite, and this increase was probably 14% compared to the non-fiber control concrete samples for all range of temperatures. As the conclusion, the durability was treated using the major indicators The analysis of the results obtained places the polypropylene fiber concrete in the same class as ordinary concrete. Secondly, the inclusion of the 0.50% volume fraction of polypropylene fiber in a cementitious composite gives significant results in terms of reducing compressive strain for temperature range of around 300 degrees Celsius. On the hand, the use of polypropylene fibers in cementitious composites increase their performance in terms of fiber resistance and can find better development application in the civil engineering market in addition to its ductile nature. Thank you for your attention.